Okay, so first, so mostly we will work on R today because I'm going to show you how to do the data analysis part of a research paper. And most importantly, I will explain from the beginning, starting from your descriptive statistic, if any transformation is required, that correlation. We'll also use PCA, principal component analysis. And we will also talk about how to do the sensitivity analysis, robustness check of your base model result. Okay. And that too using two different approaches, one based on alternative measurement unit or measurement technique, and one based on alternative econometric technique. Okay. So first thing, let me do it. I'll just delete everything and start from the beginning. Okay, so please open your Art Studio, everyone. Please do that. Open your Art Studio.
Done, sir.
Done. So what is the first step that you need to do? You need to
Library, the
first
set
thing is
working
to
directory. Working
set
directory.
working directory. If you have the code with you, then you can run the code. Otherwise, what is the process? Go to session, then set working directory, choose directory, and wherever is that folder, it is there in desktop in my case. So we'll just select that FDP underscore panel. This is my folder. Open. So my directory is set. If you have already done that, and if you have that code with you, set working directory, then you can also run that code. That will also do that. Okay. Done. Everyone done this? Setting the working directory. This is the very first step you need to follow every time you do scripting in R. Whenever you do the scripting in R, this is a must. Done, everyone? Please respond because few.
Yes, sir. Yes, sir.
Yeah. Okay. So now next thing is to call the library read Excel, right? So for that, what is the command? Library within bracket read Excel. So just run that. Then what you need to do? Then you need to load the data. How to load the data? The data that I have shared, is it an Excel file or CSV file? It is a CSV file, right? Yes or no?
Yes, sir. CSV file.
It is a CSV file. If it is a CSV file, then how to load the data? Data is equal to read.csv, right? Read.csv. I'll just do it once. Data is equal to read.csv. Then within bracket, double quote. And then you have to press what? Tab. Once you press tab, all the files that are there in your working directory will be shown. Out of this, which one I want? I want demo day 6 CSV. So just select that or press tab, it will come. Everyone is able to do it? Yes or no?
Done, sir.
Done. And then run. Once you run, it will get the data. It will get the data in the environment. That is, R will get the data in the environment. Can you see the data in the environment? Yes or no?
Yes, sir.
Yeah. So now, what is the next thing that you should do? You should take a look at the data. How to do that? You can just click on this data.
View. Okay.
Or you can do view also. That is also fine. Now see the data. Here we have bank ID. We have year. And how many banks data we have? You can see we have 50 banks data. That means 50 cross-sectional units. And how many years data? from 2010 to 2017, 8 years data. So 8 years data for 50 banks. That means total 400 farm year observations we have, right? And we have some variables. First is Tobin skew, which is basically market value of asset divided by replacement cost of asset. It's a measure of firm's performance based on market value, right? Financial performance, measure of financial performance. Then ROA, you all know, return on asset. It is also a measure of financial performance. I have got two measures of financial performance because I want to use alternative measurement technique also. Because
So
I
please
will
repeat TQ.
TQ is nothing but Tobin skew. Okay. Tobin skew is a popular measure of a firm's financial performance, which is calculated as market value of asset divided by replacement cost of asset. Okay.
Yes, sir.
Clear? ROA, you know, return on asset. So both Tobin skew and return on asset are measures of financial performance of a business. Why I have used two? Because for sensitivity analysis, I want to use two alternative measures of financial performance. This is a common practice in good paper. They will have more than one dependent variable. That means they will show the impact of independent variable on dependent variable, but they will not restrict only to one dependent variable. That is called alternative measurement model. So at least two they will have. So that's why I have taken two. That means I will show the impact of ESG variables on ROA as well as impact of ESG variables on Tobin skew, right? And then E stands for environmental score, S stands for social score, and G stands for governance score, right? So you must have heard of this ESG, very, very popular these days because lots of good works are being done on ESG, right? How ESG practices impact farm performance. Very, very hot topic these days. If you write papers on this, it is, and if it is a good design paper, invariably it will be selected because these are new topics. Okay.
Sir,
And
how do we get the data on all these?
yeah, so this is actually not this is a simulated data because I cannot share the actual data. I have worked on ESG because of the confidentiality, because you know that ESG data is not freely available, right? It has to be purchased from Bloomberg and things like that, right? So it is not a real data, it is a simulated data, but it will serve the purpose, right? I have some real data, but I cannot share that data because I myself had to, buy those data. Okay, data points. It's not really available. Okay.
Okay. Sir,
Is that
ProS and
point clear?
all these databases
No,
are good.
ProS does not have ESG data. Okay.
Okay.
Some ESG data provided by this Thomson and Reuters, they have ESG data, and Bloomberg. These two are reliable sources of ESG data. Rest all, there are some S&P also, they also provide some free ESG data, but you won't get for all the companies. Very few select companies you will get, and that too for a very limited period of time, right? So that is a challenge with ESG data. But with this data set, I will write the points, how to do the analysis and all those things, right? And it is very close to real world data. It is simulated in that way. Okay. Is it clear?
Yes, sir.
Yeah.
Sir, whatever technique you are going to teach us today, so if we are having more than one dependent variable, that is applicable on that.
Please follow me, step by step. This approach you should follow whenever you write a research paper, especially the analysis part and methodology part. This is the approach you have to follow.
So
Your
what
set
are
of
we
variables
studying
might change.
today?
Yeah.
What are we studying today?
We will be studying almost everything that we have studied in last 5 days and
Okay.
apply all those things in a in analyzing the data for writing a research paper, right?
Okay, sir.
Okay.
You said
So
something like sensitivity analysis. What is that?
that is what sensitivity analysis means, robustness test of your base model result. So generally what we do, we have only one model, right, in a research paper. That's the general practice most of us follow, right? Only one model, one regression we run, and then we say, okay, this is the result, this is the output, and this is the conclusion. But in good research paper, you need to do sensitivity analysis. That means if you say, for example, you are studying the impact of ESG practices on firms' performance, right? So you can run a regression of, say, return on asset on all ESG variables after controlling for some firm specific factors and other things, right? That you can do. Or you can also do, this is your base model, suppose this is your base model, but you can also do some sensitivity analysis. That means if you see, financial performance of a bank or of a company can be measured in different ways. That means there are different metrics for financial performance. Yes or no? Yes or no? ROA is not the only sole criterion for measuring the financial performance. So that is why you have to show, when you are using the term financial performance, then you have to show the impact of ESG variables on different measures of financial performance. Okay, is this point clear?
Yes.
So, and that is called sensitivity analysis. That means instead of ROA, if I use a different measure of financial performance, does your result hold good for that measurement also? That is called sensitivity analysis. Are you getting my point? Suppose you have run the regression ROA on ESG variables and you get certain relationship, right? A particular sign, that's positive relationship, negative relationship, whatever it is. Does the same relationship hold good if you take any other measure of financial performance? In this case, say Tobin scheme. This is called sensitivity analysis. Is it clear? Understood?
Yes, so basically robustness check.
A robustness check. This is called different alternative measurement model, because I am using an alternative measure of financial performance.
Okay.
Not only that, you have to go beyond that. Suppose you run the regression ROA on ESG variables using fixed effect model, static panel data model. So this is one econometric technique. And you do the reverse robustness check using a dynamic panel data model, right? This is also another way of doing sensitivity analysis. That means whatever you are concluding in static model, is it also holding good if you are using a dynamic model, right? So this is another way of doing sensitivity analysis. So you have two types of models, you have two types of measurement, right? So this is called sensitivity analysis or robustness check. This is very, very important if you want to get your work published in good journal. And you know that this is challenging. Why it is challenging? Because to have the same sort of relationship or same set of conclusion or result across different measurement models and across different economic models could be very, very challenging. But they emphasize on that simply because if you have successfully done all this modeling, and if you are concluding more or less broadly the same result, it means your result can be generalized and it is worth publishing. Otherwise, if you run only one model and conclude something, that is not robust enough to be generalized. Okay, it might be an one-off event. It might be because a particular sample that you have taken, that particular relationship is holding good. So you should be able to demonstrate or produce similar result using different econometric model and using different measurement model. So this is what we call sensitivity analysis or robustness check. Is this point clear to everyone? Yes or no? Hello?
Yes, sir. Yes, sir. To me, yes.
Understood? I think someone else asked me this question. Is it clear? Who asked me this question? I think
Yes.
whatever it is, I think it is clear. Secret is it clear
Yes,
now?
sir,
What
yes.
is robustness check?
Yes.
Okay. So now we have ESG. These are all scores. ESG pillar scores. TA stands for total asset. CAR, capital adequacy ratio, stands for capital adequacy ratio, right? And what is capital adequacy ratio? The capital that the bank has divided by risk-weighted assets. So it is one way of measuring the leverage of a firm, right? Those who are from accounting and finance background will understand it better. But otherwise, you just keep this thing in mind that capital adequacy ratio, measures, as the name suggests, whether the firm is having adequate capital in relation to its risk-weighted asset or not. That means more the risk-weighted asset, more capital a firm is required to have, a bank is required to have. So that ratio is called capital adequacy ratio. And then gross non-performing asset. That means when banks give out, loan, some of the loans might turn out to be bad loans. What do I mean by bad loans? That banks are not able to get the principal recovered, or they are not getting the interest on time. So then they classify those loans as non-performing assets. So what is the ratio of those bad loans to total loans? That is called gross non-performing asset ratio, right? Okay. And then CI, it stands for controlling interest. Controlling interest is equal to 1 if the controlling interest lies with the government. That means for government bank, it is 1, and for private banks, it is 0. Okay. So out of 50, I have 20 government banks and 30 private banks. Okay. This is how the data is structured. I again repeat.
Sir,
This is a
just one question. Like you have written bank ID, it is just for the purpose that you didn't wanted to disclose the name of banks,
Yes, yes.
right?
No.
Otherwise, we can write SBI or
You can write it, but see, for doing the coding purpose and analysis purpose, anyway, you'll have to drop the names, because R is not interested what is the name of the bank. R is only interested with the code of the bank.
Okay, sir. So
Right.
we have to convert that into code. That is mandatory.
Yes, yes, yes. Always.
Okay, fine. Fine, sir.
For
Fine.
your reference, you can always have. For your reference, you can always have those names, because many times in the appendix of your paper, you might have to give the list of the banks or companies that you have selected for analysis, right?
Okay. Okay, sir.
For that purpose, it is required, but for analysis purpose, names are not required. Only codes are required. Right?
Done, sir. Done. That is what I was asking. Fine.
Yeah.
Fine, sir.
Okay. Understood. Got the data, what we have. And you see, it's a very good data, because we have, alternative measurement variables for financial performance, as well as we have some, good, very, very concurrent and, relevant variables like ESG, very, very hot topic these days. Everyone is talking about it. Most of us do not understand about it, but we do it. That means we know that it's a, upcoming thing and recent trend. If you work on this, possibility of getting our work published is high, right? So let us see. I will try and demonstrate the complete process. Please try and follow me. It will definitely help. You can use similar process when you write your own research paper. You might have different set of variables, but you have to follow this structure. That means at least 2 dependent variables and at least 2 alternative econometric model you need to have for robustness check if you want to get your work published in, say, B or B plus category of journals, right? I'm talking about ABDC category, right? Okay. So let us now start. I think everyone understood what is there in the data. Yes or no? And everyone is able to get the data into your environment, our environment. Yes or no?
Yes,
Yes, sir. Yes, sir.
Now, if you look at the data, you have total asset, right? And total asset needs to be. Yes, someone please.
Tayari nimesha kutumia, taiangalia kama iko sawa.
Francis, can you just mute yourself? So now you see the total asset needs to be transformed into log version, because you see there is a huge difference in the scale, right? Huge difference in the scale, correct? Yes or no?
Yes.
Can you see that?
Yes,
Huge
sir.
difference in scale, and this needs to be converted. Otherwise, the coefficients will look very, very absurd, right? So what we will do log transformation of total asset, just to have some sort of uniformity in the scale, right? So let us do that. How to do that? Data is equal to data, and this is called a pipe symbol. Muted lnta is equal to log ta. Let me explain what does this mean. It means I want to create a new, mutate means to create a new variable, right? I want to mutate a new variable called lnta, which is equal to log of total assets, right? So I'll just give this code to your in the group, and then I will explain what it does, right? So just put it. Okay, got it? Got the code? Yes or no, everyone?
Yes, sir.
Okay. Now, is my screen is visible, right? Yes or no? Yeah. So run the code. Run the code. Everyone, please run the code. If you run the code and if you go back to data again, please run the code and go back to data. Click on this data. Now, can you see there is a new variable created called lnta? Yes or no?
Sir,
Yes, no.
this code is showing some error.
Why is it showing error? It should not show error. I just ran the code now. Data is equal
Yes,
to
sir,
data.
there's an error.
How come there is an error? See, I just run this code. Yeah, it is running perfectly fine, right?
Sir, let me write the pipe symbol myself and then try.
Yeah. Write the pipe symbol yourself. Type the pipe symbol yourself. Percentage greater than percentage. Pipe symbol is not coming properly in
Yes,
the
the pipe symbol, it cannot find the function pipe, that is the percentage greater than percentage.
now
There
is
is
it
an issue,
coming?
sir. No, sir, I have done it, but it is not coming, sir. I have written
It
it
is
by
not coming?
myself, but it is still not coming. Yes, sir.
Okay, so I think you have to do one thing then. Maybe you have to run this library, dplyr. Please run this library, everyone. Have you installed this library? If it is not installed, first install it.
No, sir.
Yeah, please install it. Maybe because of that, because it is already installed in my system, right? So just do this. Install. Everyone, please do it.
Yes, sir, it's a part of dplyr library only.
Install dot packages. Please do it. Install dot packages. Double quote. dplyr. First, please install this. I have already installed. I'm not installing it. And
It's
then
working
load
now.
that library and then run that command. It will work. Please do this. Please install dplyr package. Then call that package. Let me put this in the group. Okay, everyone, please do it. Done. Is it working now?
Yes, sir. Now it is working, sir.
Yeah, it should work because it's a part of dplyr, that mutate and all those things, right? That is why. Okay, done. Everyone, please confirm
Yes, sir. Yes,
whether
sir.
you are going to do it or
Yes,
not.
sir.
Yes, now it's working, right? So you understood what it did. It just mutated. Mutation means what? To create a new variable, right? It mutated one new variable, okay, lnta in the data. And you can see that in the data now you have lnta, a new variable. Is it clear? Everyone got this point? What we have done? Yes or no?
Yes, sir.
So let me just put these two codes before this so that when you run, it's not a problem. Okay, so we install this package dplyr and then we call that package library dplyr, and then we did the log transformation, okay, of total asset. Up to this, no problem. Now, second thing that you must do before you start your analysis is to deal with the outliers in your data, right? In good research papers, by default, they will winsorize all the non-binary variables by 1% at both the tails. What do I mean by winsorization? Anyone knows what is winsorization? Have you heard of this before? Winsorization? Winsorization is a technique to deal with outlier in your data, extreme values, which can distort your analysis because of few extreme values, your whole analysis might get distorted. So what is the way out? The way out is to, one way could be to drop those variables, but that is not suggested in good research paper because you lose observations, right? So that's not suggested. Rather, what is suggested is winsorization. That means you calculate what is the 1 percentile and what is the 99th percentile. Any value below 1 percentile will be replaced with 1 percentile value. Any value above the 99th percentile will replace with 99 percentile. Is it clear? Understood? Yes or no?
Yes.
This is called winsorization. So what we are doing, we are effectively removing the extreme values, but at the same time, we are not losing any observation. Is this point clear? But only winsorization at 1% level at both the levels, both the tails are allowed or is allowed in good research paper. And in A category papers, only 1%. In B category papers, I have seen in some papers, they also allow up to 5%. That means fifth percentile, any value below fifth percentile, you replace with the fifth percentile value, or any value above 95th percentile, you replace with 95th percentile. Okay? But standard good journals allow you only to do winsorization at 1% at both the tails. Everyone understood the concept of winsorization? Yes or no?
Yes, sir. But sir, if we do winsorization, then what will happen? Like if some values are zero, okay, like when values are not there, we put zero there. So then also it will become a value, na, sir?
That is fine. That is fine. But winsorization is a better approach instead of putting any value arbitrarily.
Okay, sir. Then what will be happening with the missing values? Like suppose there is no value in a particular cell, then what will happen to that?
So there are lots of, there are different approaches to deal with it. The most common practice is to, either you can put zero, that is one approach. Some people put the mean of that particular variable there. Some people put the previous value, last year's information, right?
Okay, sir.
Okay. So these are different approaches. There is nothing called right or wrong, but in good papers, generally what I have found that they use previous year's value. Suppose if the missing value happens in between 2 years number, so you fill it by the previous year's. Okay.
Okay, sir.
There is nothing called right or wrong. So these are, all these are acceptable approaches, not a problem, right?
So is it accepted? Like if I put the previous year's value, for
yes,
example,
yes,
2 years value
it will be accepted. It will be accepted, not a problem. And most importantly, these things are never reported in the paper.
Okay, sir.
Okay. Who will report all these things in the paper? You tell me.
No, sir.
Everyone knows that these are common problems, and everyone does this.
Yes, because
right?
in the Indian context, data is not normally data are not available.
Yeah, it is absolutely accepted. Not an issue at all, right?
Basic data cleaning process. So
yeah, basic data cleaning process. Either you put zero, some people replace it with mean, some people replace it with median, some people replace it or substitute with the previous year's number, right? All are accepted. Not an
Okay.
issue.
Okay, sir. Understood, sir.
Yes. So, but you understood what is winsorization, right?
Yes,
okay.
Understood, sir. Understood.
Yeah. Now, I'll just give you the code for doing the winsorization, and then I will try and explain what this code is all about, and what I am planning to do for three things: for winsorization, descriptive statistics, and PCA, and correlation matrix. I will give you one handout, that means a soft copy of detailed explanation of the code, because these codes are very lengthy, right? Anyways, you'll have to copy and paste it. But if you want to understand what the code is doing step by step, I have one document where I have explained all those things that will be shared with you probably after the class or tomorrow morning. I will share that. You can go through it. But for the time being, you'll have to copy and paste. I will give you the basic idea what is going on, because these are lengthy things. So it is good to have that detailed explanation for, so that you can replicate the same codes by simple, change by changing your variables and all those things in other contexts. Okay, that I will do. So first, let me give you this code for defining a function for winsorization, and then I will tell you what this code is doing. And first, let me put it in the group for winsorization. Got the code, everyone? Yes or no? Have you done the coding?
Yes, sir.
Have you? Yeah.
Yes, sir. Yes, sir.
So now let me just explain quickly what is going on here. Don't get scared, but if you try and understand, it will be clear to you. So I'm trying to do winsorization. So first I'll define that function. So x is my variable that I want to insurize. No, I'm generalizing. X is my variable that suppose I want to insurize. So you'll have to tell the lower percent, that is 0.01, because I want to do the winsorization at 1% at the lower. And if it is 1% at the lower, then the upper percentage will be what? 99%? Yes or no? Yes or no?
Yes, sir. 100 minus 99. 100 minus 1. That is 99.
Correct. Okay. And lower limit is the what is the lower percentile? That means, see, here I have defined the percentile. Now I am telling what is the quantile. Quantiles are all percentiles, right? Percentiles are also quantiles, right? Okay. So say for example, here I am telling quantile is lower percent, that is first quantile or first percentile, correct? And upper limit
तो
is
इसमें चल जाएगा
99%.
वो यार काकाशी से जुड़ नहीं पा रहा.
Hello. Okay. Fine.
क्योंकि
And then
विशाल 4G यहाँ पे आ नहीं रहा ठीक से.
is
देखिए
anyone
काकाशी
saying
में
something?
कि वह बड़े से है क्या?
Please mute, someone is talking. Please.
Vishal Dubey is talking.
Oh, sorry, sir.
Vishal sir, please can you mute yourself? Okay. So
Yes, sir.
first,
I mute.
yeah, first I am telling what is my lower percentage, what is my higher percentage. It is nothing but first percentile and 99 percentile. Then I will calculate the first percentile and 99 percentile. This is the lower limit and upper limit. And then what I'll do, any value below lower percentile will be replaced by the lower limit. Similarly, any value above 99 percentile will be replaced by the upper limit. And then it will return x. That means after doing this replacement, it will return x. This is what it means. In simple words, let me give you one explanation. Suppose your E score, you calculate the first percentile of E score. Suppose first percentile of E score is 5 and 99 percentile of E score is say 55. Okay. It basically means any value, any E score below 5 will be replaced by 5. Any score above, what is the 99 percentile I said, say 45. Any E score above 45 will be replaced by 45. This is what we mean by winsorization. Is this clear to everyone? Yes or no? Is it clear?
Yes, sir. Yes, sir.
Yes. So I will first decide what is the percentile that I will take, whether it is 1%, 5%, 10%. We generally do it like this: 1%, 5%, 10%. Right? Suppose we have decided 1%, and we will do 1% because good papers only accept 1%. So 1% and 99%. So first percentile and 99 percentile will calculate. So first percentile will be the lower limit, 99 percentile will be the upper limit. Any value below first percentile will be replaced by the first percentile. Any value above the 99 percentile will be replaced by 99%. This is what we mean by winsorization. I hope this is clear to everyone now. Yes or no? Clear? Understood? Yes. Next. Now apply. I want to do this winsorization to non-binary variables. There is no point doing winsorization to binary variables because they take only 0 and 1, right? So apply winsorization to non-binary variables. So now you see what is being done. Same thing. I'm just giving you the code. Please do it. Everyone understood the basic idea behind this code, right? Yes or no? Yes or no? Please confirm. Yes,
so in
everyone
the previous code, like in the previous command, we have just like what to say, we have what to say, define the function only.
Yeah, we have defined the function only. Yes.
Or now we are applying it to the variables.
Yeah, now you are applying.
Okay,
Yes.
okay, understood. Sir.
Okay. Clear? So please run the code and then I'll explain what is basically being done.
Done, sir.
Now you see, I have in my environment, we have a new data that is called win data. This is nothing but winsorized data, right? In this data set, all the variables are winsorized at 1% at both the tail. This is what we have done here, right? Yes or no? That means if you try to understand this code, what is going on, the new data set name is given as win data, that is winsorized data. Now I have done winsorization on which data? On these variables. But these variables are mainly coming from which data? Which data set? That is called data. So this is called pipe operator, right? Correct? So it means the, I am taking from this data set through this pipe, I am applying mutate to these variables. This is what it basically means. Okay. Is it clear? So if you do not understand, not an issue because you have to just go by the codes, but this is what it means. So I have created a new data set called winsorized data. To create this new data set, which data set I have used? I have used this data, which is originally my data, correct? And then I have used a pipe to apply mutate to all these variables, okay, which are there in this data. Now, whatever variables that I have under this particular data set, if I click, these are all winsorized by 1% at both the tail. I hope this is clear to everyone. Yes or no? Is it clear? Yes or no? Understood?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Yeah. So you can just see the data head, just some few of the I think first six data points will be shown if you use this, but it is not required. So winsorization is done. So next step is to generate the descriptive statistics. To generate the descriptive statistics, you have to install a package called PSYCH. Can you see this? So I'm just giving this because this you have already installed. So just please get this installed and loaded. I'm just sharing you the okay, done. Everyone got the code? Please install this package and then call that package or load that package. Library PSYCH. Have you done these two steps, everyone? Yes or no? Please confirm whether you have done it or not. Okay,
Yes, sir. Done, sir.
done?
Yes, sir.
Next. Now I will generate descriptive statistics for non-binary variables. Yes or no? Because for binary variables, there is no point calculating the descriptive statistics. Suppose there is a binary variable taking the value of 1 and 0. What is the point of calculating mean of that? What is the point of calculating standard deviation of that, right? What is the point of calculating minimum and maximum? Those things won't make sense. So what I will do the, descriptive statistics or generate the descriptive statistics only for the non-binary variables, right? So select only non-binary variables. So I'm giving the code. Select only the non-binary variable. Do it. Right? So non-binary variables, just run the code. Okay. So now you have a sub data set which contains only non-binary variables. How many non-binary variables are there? PQ is a non-binary variable, ROA, E, S, D, LNTA, PAR, and GNPA. These are all non-binary variables. Okay. So I have created a sub data set with all non-binary variables. This is what we have done. Now understand the code, what is going on. I'm saying the name of the data set is non-binary variables, right? And it comes from which data? Winsorized data. Then I have applied pipe to select these variables which are originally there in win data. This is what it basically means. Okay. Is it clear? Everyone done?
Sir.
Done this? Yes or no?
Yes, sir, done.
Done. Next, I will calculate the descriptive statistics for all the non-binary variables using this code, right? So let me give you this code. Just run the code. So you see what all things I am calculating. I am calculating mean, median, standard deviation, minimum, max, skewness, kurtosis. And I am using transpose to improve readability. That's it. Okay. There is no point memorizing this code. This will be given to you. Just understand what is being done. Right? Okay. So just run the code.
Sir?
Yeah.
Sir, there is a package called F Basics.
There are different packages that you can use.
So, I mean,
But I'm using this package simply because in other packages, you may not be able to calculate skewness and kurtosis. Okay. Because descriptive statistics can be calculated using different packages, right? That is not a
Right,
problem.
right.
But skewness and kurtosis, for calculating that, you need this. Okay.
Okay.
Because in general, if you go for descriptive statistics, it is what all things are reported under descriptive statistics: mean, median, then standard deviation, minimum, maximum, right? The skewness and kurtosis by default are not reported, right? So if you want to see skewness and kurtosis also, then you can use this. In fact, in many research papers, most of the research papers, they do not report skewness and kurtosis. But it is very important to, at least at your personal level, you should look at the skewness and kurtosis, because that gives you some idea about normality of your data, right? Variables, right? So if these two are significantly, different from the skewness and kurtosis of normal distribution, this will create a lot of trouble when you do the modeling, right? Yes or no? Correct.
Yes, sir.
If your data is very, very skewed, right, that will create problem. Kurtosis, if it is, what you call leptocartic, that might also create a problem, right? So it is better to take a look at it. And sometimes if these things are beyond a particular level, then you might have to do further transformation in your data before you do the modeling. That's why you should always take a look at skewness and kurtosis. Even though we do not report skewness and kurtosis under descriptive statistics in the research paper, right? But it is a good practice. Before you start modeling, you should look at it. Okay, have you executed this command, everyone? Yes or no? Yes or no? Done. Hello.
Yes, sir.
Yes, is it done?
Yes, sir, yes, sir,
Done.
done, sir.
Now we will just do some basic decoration work, that is converting the output into a data frame, right? And then we will export them into Excel sheet in CSV. I'm just giving you the commands and just execute these commands. Someone is waiting in the I do not know, but is it not? It is not showing. Can someone write in the group that ma'am should just log out and try and enter again? Then I'll be able to. I think it is not showing here. I don't know. No, nothing is showing here. Okay, done. Have you completed up to this?
Yes, sir.
Yes. So just I'm just running the codes, and let me take a look at the descriptive statistics, right? So this descriptive statistics will be there in your working directory. It will get saved in working directory. So I have named it SS, summary statistics. So let me look at the summary statistics. SS. Here it is. Okay. You see, skewness and kurtosis, these are the two things I am interested in. Rule of thumb is, if skewness and kurtosis are less than 1, that is the best to proceed with the modeling. But in financial data, kurtosis at times may be very high, because financial data by nature, are leptocartic. But you have to at least ensure that skewness is less than 1 before you start doing your modeling. Otherwise, it will create a lot of troubles, right? Okay. So for our data, more or less everything seems to be fine. And winsorization helps in this regard, because we are calculating descriptive statistics after winsorization, because all the extreme values are already removed, right? So because of the extreme values, you have that skewness, right? And kurtosis also may be there, because heavy left tail might be there. So after winsorization, most of these problems should go away. Even after winsorization, if the problem persists, then you have to do further transformation to your data before you get into modeling. Otherwise, you will not be able to meet the assumptions, that is the diagnostics of your model, right? Diagnostic test of your model. Okay, is it clear? Everyone understood this? These numbers are, because if they are normally distributed, then these numbers will be what? Skewness will be 0. Yes or no?
Yes, sir.
Yes or no?
Yes, sir. Yes, sir.
And kurtosis is reported as excess kurtosis. What is the kurtosis of normal distribution? 3.
3. Yes, sir.
Yeah. So excess kurtosis should also be 0, but it is, I think manageable. So
Yes, sir.
everything is within 1, right? Plus minus within 1, right? So it is not a big problem as such, because we have already winsorized the data. So after winsorization, if we get this sort of numbers, it is not surprising, right? Because we have already removed some of the extreme values from the data. Okay. So it's okay. Good to go ahead with this. Okay. So let me now proceed. We'll now pick up speed. Everyone understood what I am basically trying to do? And see, these are preliminaries you must do before you start doing the modeling, right? These are basic data cleaning that you must do before you start doing the modeling. Otherwise, it will be very, very difficult for you to meet the model assumptions, right? Is it clear? Everyone understood what we have done so far? Yes or no? So first we did what? Winsorization. Then we generated descriptive statistics to check whether we are kind of achieved some sort of normality in our variables or not. Exact normality is not possible, but at least rule of thumb is make sure that your skewness is less than 1 and kurtosis less than 2 at the most. But for financial data, it may not be possible to restrict all the kurtosis numbers less than 2. So little more than that is still okay. But at least you have to ensure that your data is not heavily skewed, right? Then it is going to be a problem. This rule of thumb is generally mentioned in there is a famous book by Black and Hare, right? So in multivariate statistics, so there they have mentioned this is a rule of thumb, but in financial data you might have little higher kurtosis, so that is okay, we can manage that. Okay, now third thing that we need to do is correlation matrix. Again, correlation matrix, for this I need this package called HMISC. So I'm just giving these codes to you, right? And please go ahead and install the package, because I don't think you have this package, right? Please install this package, everyone, and then call this library. I have already got this installed, so I'm just calling this library. Please do it, everyone, for correlation matrix. Okay. Done? Have you installed and loaded the library? Yes, package? Yes or no?
So still running.
Yeah. Done? Yes, please respond, others.
Still running, sir.
Okay. Oh my God.
Sir, it is throwing an error that this package is not available for this version of R.
Oh, then to gone get. So then to you have to just observe what I'm doing. Later
There
on
is
you can
a
update.
there is a
Yes.
command called update.package and give the name of the package. The version can also be controlled.
Yeah, so that can be done. So if you can do it, very good.
Update.package, and then I should give HMISC.
Update.package and into bracket, into inverted comma, the name of the package.
Right. Okay.
If it works fine, otherwise just just observe. Later on you can do that. That's not a problem, right? Because it's just a part of it, correlation analysis, because later parts will not be impacted by this. You just need to understand how to make sense of the correlation matrix. That's it. Okay. If it works, very good. Otherwise, you can just leave it for now, right? For others, is it working? For some of you, at least you could update and install it. Yes.
Yes, I have updated the package, sir.
Yeah. So are you able to load the package? Library HMISC, is it working?
No, sir, library. But library is not working. I don't know, sir. But I have updated. It is showing blue. That is, it got updated, but library is not working.
So library is working fine with me. If it does not work, not to worry about it. Just let me explain the process and how to make sense of the correlation matrix. That's what is very, very important. Okay. Anyone who could load the library HMISC? Anyone? No one could do it? I'm just giving the rest of the codes to do the correlation matrix. Okay. And I will just explain the final matrix, right? And as I told you, I'll give you a handout explaining each and every point of these codes because these are lengthy codes. But here, let us spend the time in understanding the output. Okay. So please confirm anyone who could load the package.
Yes, sir. Yes, sir. I have done it, sir.
Is it working?
Yes, yes. Now
I have
it is
also
working,
given
sir.
you the codes now.
Yes, sir. I
to-
have checked, sir. Yes, sir.
Yeah.
To run the that is
Basically,
the
what
code.
I'm doing, I'll be calculating the Pearson's correlation coefficient. And you know that Pearson correlation coefficient makes sense only when the variable is non-binary, right? Yes or no? So for non-binary variables, I'm going to calculate the correlation matrix, right? Okay. And I also want R to tell which correlation coefficients are statistically significant at 5% level. This is the code. And I have also instructed R to, round the correlation coefficient to 5 decimal places. Correct? I have given you the codes. So please do that. Those who could upload it. And then I will go to the package. I'll go to the metrics CSV file. So I have exported the output into a CSV file and I have named it correlation, that is core, right? I have named it core, right? So everyone please do up to this.
I have done it, but mostly all of the variables are correlated, like ROA to TQ and all.
Hello. Hey, Bill. Hey, coffee. Oh. Inaitwa business economics.
Okay. So have you done this? So let me go to the correlation matrix. Those who could do it.
Hiyo business economics ni part ya economics.
Correlation matrix. COR.
Ina focus kwenye business zaidi.
Someone
Yani
needs
ni
to.
uchumi kwenye biashara.
Yes, who is talking? Please mute yourself.
Uchumi kwenye biashara. Yeah.
Francis,
So
can you just mute?
If it is possible, you can also mute him, sir.
I am muted. Okay, fine. So can you just okay. Someone is saying I'm not able to work on the R code. It's okay. Later on you can watch the video and get it done, not an issue. Okay, so let me just go to the file correlation, right? Please pay some attention and try and make some sense out of it. See here, it is written 1 NA. So it is basically 1, right? What does this mean? It is basically referring to correlation between Tobin skew and Tobin skew. So it has to be 1, yes or no?
Yes, sir. Yes, sir.
Yes or no?
It has to be 1, sir.
So you can just write 1 here. Okay. And this with little bit of formatting, you can report in the research paper. So you see how to read these numbers. See, it basically means correlation between TQ and ROA is 0.93, which is statistically significant. Correlation between TQ and E is 0.69. Correlation between TQ and S is 0.63. And TQ and G is 0.52 approx. And these are all statistically significant. Correlation between TQ and LNTA is 0.08, which is not statistically significant. Correlation between TQ and CAR is 0.75. And there is a there is a negative correlation between GNPA and TQ. Okay, fine. Everyone understood? Yes or no? But please do not get too much into the correlation matrix, because these are all univariate analysis. Univariate in the sense bivariate, rather, you can say, just two variables. But when you talk about the relationship in a multivariate context, this game might change altogether. Did you understand what I just said? Yes or no?
Sir, can you just repeat, sir, what you have said, sir?
What I'm saying is, these are a bivariate relationship, right? That means you are just talking about relationship between, say, for example, this CAR, capital adequacy ratio, and TIC. It's a relationship between these two. But when you include many more variables in your model, the relationship might change. Yes or no?
Yes, sir. The relationship will change, sir.
Yeah, will change. So that is why what we are seeing, this is just a beginning, as a starting point. This is just a starting point, right? To see if your regressors are having strong correlation or not. If two regressors are having very strong correlation, then it might create multicollinearity problem later on. In that case, you might have to drop one of the variables which are highly correlated, or you might have to use PCA to actually, have what you call an index combining variables which are highly correlated. Okay, that's the only idea behind the correlation matrix. Nothing much. Because
So in that case, the many variables are highly correlated to each other, sir.
No, not highly correlated. Regressors are not very highly correlated. See, PQ and ROA will be highly correlated. Why? Because they are two alternative measures of financial performance. Yes or no?
Yes, sir.
They will be having high correlation, but rest all are, I think, manageable. Not that much of a problem, right? Yes or no? So
yes, sir,
you have to just ensure that regressor should not have high correlation. Say any correlation with more than 90% and all between two regressors, then that will create multicollinearity problem, right? Otherwise,
yes,
it is okay. Okay?
Okay, sir. Okay, sir.
Understood how to make sense of the correlation matrix and what is the use of correlation matrix?
Yes, understood.
Everyone got the point? Yes or no? Please confirm whether you have understood this or not. Yes or no?
Yes, sir.
Understood?
Yes, sir.
Okay. So let me go back to the codes again. Now, after doing correlation matrix, the next thing that you need to do is, you see, in our data set, we have what we have? We have E score, we have S score, and we have G score. That is environmental score for a bank, social score for a bank, and governance score for a bank, right? But we do not have any composite score. One way is to find out the composite score, to find out what? Just take the simple average of those three scores and you call it ESG score. But in good research paper, if you simply use a simple average, they will ask you questions, right? You cannot just do simple average. You have to justify the weights. In simple average, every component is given equal weight. If there are three variables and if you take the simple average of that, so every variable is given 1/3 weight, right? How do you calculate average of three variables? E plus S plus G divided by 3, right? So everyone is getting 1/3 weight, equal weight. But ideally, the weight should be given based on the ability of a variable, or rather I should say, based on the ability of a variable to explain the variation in data set. Ability of a variable to explain the variation in the data set. The variable which is having higher ability to explain the variance should be given higher weight and things like that. Okay, and this is the process that is actually done in the back end when we do the PCA, principal component analysis, right? So what I will do, instead of taking simple average of E, S, and G, I will use principal component analysis to decide how much weight should be given to E, how much weight should be given to S, and how much weight should be given to G. Okay, and based on these weights, I will calculate weighted average, not simple average. We will calculate weighted average. Weighted average also is a simple average is also a weighted average. Weight is equal, but I will give different weights to different component, right? Based on their ability to explain the variance in the data set. And that objective can be achieved using principal component analysis. Is this point clear to everyone? Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Using principal component analysis, we will decide how much weight to be given to E, how much weight to be given to S, and how much weight to be given to G. And using those weights, I will calculate weighted average. And that weighted average will be called the composite PSG score, right? Okay. Is this point clear? So let me give you the codes for, and then I will try and,
So principal
out.
component analysis is just like is a factor analysis, how it is going
Yes,
to
yes.
decide about weights.
I'll tell you. Just a minute. From factor loadings, we can calculate the weights.
Okay, okay, sir.
Factor loading, from factor loading, we will calculate weights. Just see the codes, you will understand what is going on. Okay, so let me give the codes first, and then we will talk about it. Okay, have you got the codes, everyone? So first of all, what I'm doing, so this also will be done using this dplyr library. So just run that library once. Otherwise also fine. So I will create a separate ESG data. So ESG data from this winsorized data, I will just select only E, S, and G because I need to combine these three. So this is what is done here. Then I will perform PCA analysis, principal component analysis on this ESG data. And what is this? Center is equal to true, scale is equal to true. Those who have done PCA, we need to first standardize the variables, right? Yes or no? How do I standardize? Each variable, each observation is deducted from each observation, its mean is deducted and it is divided by standard deviation. So by center mean will be deducted and scale is equal to true means it will be divided by standard deviation. This is how we do the standardization. Okay. Then we will calculate the loading for each variable, and we'll calculate weight based on loading of a particular variable divided by sum of all the loads, right? Correct? And then I'll just want to, display the loads, and I am giving a rounding of 5 decimal places, rounding of 4, right? That means I want the loads to be rounded to 4 decimal places, sorry. And then finally, I'm printing the weights. Okay. So what are the weights that I have got? So I am getting very close to 1/3, but this weights I can justify because I have not decided the weight arbitrarily. I have decided the weight based on principal component analysis, right? So ideally, I'll have to give 34.42% weight in E score, 33.38% score to S score, and 32.19 score percentage weight to G score. And using these weights, I will calculate weighted average, right? Everyone got up to this level? Yes or no?
Sir, we have different scores for E, S, and G components. So now, because we want to calculate the composite score for ESG, that is why we are doing this. But in case if
Yes,
we do not
absolutely.
have this ESG variable in our data set, we don't need to perform principal component
We
analysis.
do not need to perform this. And this also serves another purpose. When two variables, two regressors are highly correlated, then you might want to combine them and create one index, right?
Oh, okay, sir. Got it.
In those cases also you can use PCA.
Right, sir. Right. Absolutely right.
Correct. But here that's not the purpose. Here the purpose is to calculate the composite score, and I cannot, decide the weights arbitrarily. If you do that, then it will be very difficult to defend in the paper. But if you do based on PCA, then you have a basis that I have not decided the code, the weights arbitrarily, but based on their ability to, explain the variance in the data, I have used PCA to figure out how much weight should be given to each and every component. Okay. Is it point clear?
Yes, sir.
Sir, I haven't understood that standardization thing, sir, like the scale and center.
Scale and center means how do you do standardize a variable? X minus mean of X divided by standard deviation of X.
Yes, sir.
That
Yes,
is
sir.
what is the code. Center means mean.
Mean. Acha. Mean is true. That is
Scaling means dividing it by standard deviation.
okay. Understood, sir.
Okay. Fine. Okay. So once you have got the weight, then you see in this code I am just calculating the weighted average. You see how this weighted average is calculated. E multiplied by weight of 1, that is the first component. Then S multiplied by second component, plus G multiplied by third weight. So I am basically calculating weighted average. Okay. So if I run this code, I will get the weighted average. Okay. Is it clear? I will get the weighted average. So what is the name that I have given to that composite ESG score? I have given name. What is the name I have given? CESG. CESG stands for composite ESG score, right? Composite ESG, composite ESG. Now, if you go to winsorized data, you will have a new variable called, what will be the name of the new variable? CESG, composite ESG score. Can you see that? Now we have a new variable called composite ESG score. How this is calculated? This is E multiplied by the weight of E plus S multiplied by weight of S plus G multiplied by weight of G. This is how it is calculated. Now we have a new variable called ESG. This is what we have done. Is it clear to everyone? Yes or no? Yes or no? Yeah. So this is simply the weighted average calculation, but weights are determined based on the PCA technique. Weights are not determined arbitrarily. Neither we have given equal weights, right? And what is the basic funda behind PCA? Those who have studied factor analysis before, you know that. So PCA or factor analysis is often called a dimension reduction technique, right? But this can also be used for deciding the weights. Weights are decided based on factor loadings. Loading of a particular factor divided by total factor loads, right? Can
Sir,
help
but
you
in
decide.
this case, the weights are almost equal. So it is 0.34, 32, and
It
33.
is almost equal because it's a simulated data set. That is why it is coming like that, right?
Okay, got it.
But in real world, the weights will be quite different, right?
Okay, sir.
Yes or no? So I'm telling you how to approach this. Don't go by the numbers. Understand the process and why it has to be done, right? Yes or no? So because when you work on a different data set, which is a real world data set, not a simulated one, then you will find because different variables will have different level of variability, right? Accordingly, different weights will be assigned to them. Is it clear? Understood?
Yes, sir. Yes, sir.
That means instead of you deciding what should be the weight, your data should decide, or data should dictate what should be the weight given to the variable based on its ability to explain the variance in the overall. Okay, that's the basic idea behind PCA and deciding the weight. Okay, so now we are in a position to run the model, right? So we have done what? We have done the log transformation of total assets. Then we did winsorization. Then we calculated descriptive statistics to check that normality is not an issue. Then we did descriptive statistics. Then we did after descriptive statistics, we did the correlation analysis, correlation matrix to check that two regressors should not be highly correlated because that might create a multicollinearity problem later on. And we have to also ensure that our alternative measurement variables are strongly correlated because they are alternative for one another, right? So in our case, ROA and Tobin skew are highly correlated. So that is serving our purpose. And then finally, we computed the composite ESG score because we do not have the composite score, we only have the component score. And to decide what should be the weight given to each of these components, what we have done, we have used principal component analysis, wherein weights are decided based on factor loading, right? Fine. Okay, can we proceed now with the modeling part now? Yes or no? Hello, up to this, are you with me? Yes or no?
Yes, sir.
Yeah. Now what I will do, I will now first load this TLM package. So just do this TLM package, load this TLM package and dplyr. Anyway, it is already loaded, but there is no harm if you load it twice, not an issue. So just do this. CLM package is already installed in your system because we have done panel data models earlier. LM stands for linear model. ELM stands for panel linear model, right? Yes or no? So now we are in a position to declare the data as panel data. So after doing all the data cleaning and all basic things, now we are declaring the data as panel data, right? How to declare the data as panel data? This is the code, right? P data is equal to P data frame, winsorized data, and then index. C bank ID is your cross-sectional identifiers, and here is the time identifiers. I'm just giving the code in the. Please do this. Someone is at the door. Let me just check. Please complete this, everyone. But around 10 out of 4. By 10, it will be over. Okay. Okay, done, everyone. Completed to this. Yes or no? Have you declared your data as panel data? Everyone?
Yes, sir. Done, sir.
Done. Have you declared your data as panel data? Everyone, please do it.
Yes, sir.
Then I will do lag creation. This is for a precautionary purpose. If you have to use lags as we might have to lag the independent variables by a year. So for that purpose, I will create the lags before I go ahead and do the modeling, right? So how to create the lags? I may use it, I may not use it. That's a different purpose, but I'll just have to make sure that the lags are created. If they are not created later on, then that will become an issue. So I'll just create the lags and keep them ready. If I use them, very good. If I do not use, not an issue, right? So I'll just give you the codes for creating the lags. You know these codes because we had discussed these codes earlier. So I'm not getting into what the code is all about because you must be aware of these codes because in other classes also we used it. Yes or no? Are you able to do up to this?
Yes, sir.
Yeah. Yes. What about others? Able to do? First, declare your data as panel data. These are all old codes. I'm not getting into these codes because we have done it several times, right? Yes or no?
Yes, sir, done.
Done. Okay. Next. Now I will do the coding part for modeling, right? So what I will do, by default, we will use what? Fixed effect within group model. And I told you, you do not have to report Haussmann test also. By default, we'll go with two-way fixed effect model. Now, whether it is two-way or one-way, how to decide whether I should go for two-way or one-way? Ideally, I should go for two-way simply because I have not control for the macroeconomic variables. Do I have controls for the macroeconomic variables in my data set? No, right? That means I do not have GDP, inflation, interest rate, and things like that, right? I'm not controlling them. So ideally, I should have time fixed effect also in my model. So I should go for two-way fixed effect model. Okay. Is this point clear to everyone? Yes or no?
So if I include GDP and that is macroeconomic variables, then how like it will be impacting that the results?
If you include those things, then you need not include the time fixed effect.
What is the reason behind this?
So that is what I explained it once again.
Yes, sir. Yes, sir. You have, but
the macroeconomic variables change over time, right?
yes, sir.
But they are constant for all the cross-sectional units.
Yes, sir.
So if GDP is growing at 7%, the
Yes, sir.
impact of that growth is same for all cross-sectional units.
All
It is not
cross-sectional,
7% for SBI. It is not 8% for Bank of Baroda, right? It is 7%. So it is constant. It is fixed for all cross-sectional units,
cross-sectional
but
units.
over time it is changing. That is why it is called time fixed effect. So they are time variant, but cross-sectionally invariant.
Understood.
So what is the impact? What is the role of a time dummy? They change over time, but they are fixed for cross-sectional units. So either you use your macroeconomic variables as controls, or you use time dummies.
Okay, sir.
Don't use both.
Okay, sir. Understood.
I prefer to use time dummies simply because if you use time dummies, all the macroeconomic variables are indirectly getting captured, right?
Yes, sir.
But if you use the macroeconomic variables as control, then how many macroeconomic variables will you capture?
There are many variables. So
there are many variables. You cannot capture each and everything. Even after you take 5, still there might be some macroeconomic variables that you might have missed out. So better to take the indirect approach of time dummies, which will capture all the macroeconomic shocks, right?
Yes, sir. Factor within type.
Yes. So that is why I prefer to use what I prefer to use time fixed effect. So basically, you go for two-way fixed effect model, right? Yes or no?
Yes, sir. Yes, understood. Yes, sir.
Now the question is, should I use lag or not? In this case, I have not used lag. That means I have not lagged the independent variables by 1 year. That could be a good approach, but always you have to see which one is giving you better result. I tried with first lag, but it was not giving me a very good model. That is why I have gone back to levels. I've removed the lag. So as a homework, you can try running this model by lagging the independent variables by 1 year, and you will see your R square, adjusted R square will become negative. I'm not showing it. You can do it at home because otherwise I will not be able to complete the whole thing. That is an assignment I'm giving as a homework. You try that. That means instead of, see, what is the model I have used here? My dependent variable is ROA, and independent variable is composite ESG, LNTA, CAR, and GNPA, right? Instead of doing that, I could have taken first leg of composite ESG, first leg of LNTA, first leg of CAR, and first leg of GNPA. That can also be done. So that is what I'm asking you to do as a homework. And you will see that for that model, your R square will be very, very low. And in fact, your adjusted R square goes into negative. Now you might think that can adjusted R square be negative? Those who are from econometrics or economics background, can you tell me, can R square, adjusted R square be negative?
Because it's R square. So it cannot be negative.
Adjusted R square can be negative because R square cannot be negative. Adjusted R square can be negative because there is a penalty factor, right? For using more, if you use more independent variable regressors, but if those regressors are not adding to the explanatory power of the model, then adjusted R square penalizes them, right? Yes or
Right.
no?
Yes.
So if you are adding too many regressors, and if those regressors are not adding any explanatory power to your model, then R square, adjusted R square might turn negative. So that's not a good signal. It means your model is faulty. So I tried lagging the variables, and your adjusted R square turned negative, and R square was very, very low at around 4%, right? So I dropped that idea and I went back to the independent variables at levels. So you can just try that at your at home as an exercise and see what is the result you are getting. And this is definitely a better model. So that's why I have not lagged. And that is the thing I keep on telling. There is nothing called the right approach or the best approach. It is always you have to explore different options and see which one is giving you better result and the result that you can defend, right? Is that point clear? That is why I have not lagged it. Okay. Okay. Can I now proceed with the
Yes.
modeling part? Yes or no?
Yes,
So
sir.
just
Please
let me
proceed.
give you let me give you the codes. Let me give you the codes. Should I give all the codes in one go? I think I should give all the codes in one go so that we can focus on the interpretation part of it, right? Instead of doing because these codes are nothing new. We have done all these codes earlier. Only thing I have just taken the robust standard error as well. I'll explain all the codes. First, let us do the clerical part, and then I will explain the codes. So one by one, just run the codes. First, I am running this code. And your summary. So what is the model summary? Have you got the summary results, everyone?
Yes, sir.
Can you take a look at it, the output? What is going on here? You see, ESG has a positive impact on ROA, right? Yes or no? Positive.
Yes, sir.
And it is statistically
Significant.
LNTA is also statistically significant, but it is having negative impact. And same thing we got in earlier result also, right? Capital adequacy ratio is having a positive impact, right?
Yes.
Yes, sir.
And
GNP
gross
is negative.
NPA is having negative impact. All the signs are more or less in right direction as expected.
Yes, sir.
Okay. Fine.
Yes, sir.
So this is a result that you can easily defend. It's not a problem. Okay. Now you can go ahead with plotting the residuals. So just click on this, extract the residual, then the density plot. These are all old stories. We have done this several times. And you see your density plot of the residual looks quite good.
Impressing, sir. Yes, sir.
It looks like normally distributed. So it means the model is pretty good, it seems, right? Okay. But as I told you earlier, every time you report your coefficient in the research paper, you must use robust standard error. Why we should use robust standard error? Because many of the regression assumptions we may not be able to meet in real world, like heteroscedasticity, any other say related to autocorrelation and normality of the residuals. We may not be able to meet all the assumptions. So what is the compensation that we have to pay for not able to meet all the assumptions? We'll have to penalize the standard error by taking the robust standard error, so that less number of variables appear to be statistically significant. So this is the what you call damage control we need to do for not being able to meet all the assumptions of the model. And this is a standard practice in all research papers. You will never ever find that they have reported the diagnostic tests after running the fixed effect model. Only thing that they will report that they have used robust standard error. It's a standard practice and well accepted, because most of the times you will not be able to meet the heteroscedasticity assumption, because it's very difficult to meet. Can variance remain constant? Answer is no. Yes or no?
Yes or no?
Answer
Yes,
is
sir. Yes.
no. So you will
No,
never
no,
ever.
no, sir.
It's very difficult to meet this assumption, right? So what we do, we accept the fact that many of these assumptions may not be met. So we just penalize the standard error by treating them as a robust standard error. And you have seen that robust standard errors are higher than the normal standard error. And as a result, less number of variables will appear to be statistically significant. So that's the price you have to pay for not being able to meet all the assumptions. And this is a standard practice. You look at any research papers. So at the most, as a diagnostic test, they report robust standard error. Okay. So same thing, we'll also do it here. So we'll compute the robust standard error, and those robust standard error will be reported in the research paper, right?
Now LNTA is not significant.
So because I am penalizing the standard error, so some of the earlier significant variables will now become insignificant, right? Okay, understood?
Sir,
You
now
see
if I
LNTA
report, okay, sir, sorry, sir.
Tell.
Sir, now if I report this result, then how much study is novel, sir? Like it is insignificant, all the variables are insignificant.
Where all the variables are insignificant? Only LNTA is
Oh,
insignificant.
sorry, no star is there. I haven't checked, sir. Sorry, sir.
Okay, p values, you look at p values, na?
Yes, sir, I
But
forgot.
when you report in the research paper, you report these coefficients. But for model fit and all, you go by these results. That means F statistics and all. See, in this, F statistics and all are not reported, because whether you are using robust standard error or not, that is not going to impact your F statistics, right? It is going to only impact whether the variable is statistically significant or not. And estimates are also not changing. These are all same. See, without robust standard error also, you will have the same level of estimates. Only thing, statistical significance will change, right?
Yes, sir. Yes,
Are
sir.
you getting what I'm saying?
Yes, sir. Yes, sir.
Right?
Yes, sir.
So you are basically changing the standard error. Robust
Yes,
standard
sir.
error will be higher than the normal standard error.
Normal standard error. Yes, sir.
Correct?
We have
So
discussed it before, sir.
as a result, see, how do you get this t value? This estimate divided by standard error. If you increase them, then t value will go down. If t value goes down, then probability will be what? The possibility of that variable being statistically significant goes down, right?
It goes down. Yes, sir.
That's the basic thing. So
Yes,
you
sir.
will report these, statistical significance based on this robust standard error. But your model fit and all, everything will be reported based on the earlier model.
Earlier. Oh, okay, sir.
Here your F statistics is given, and F statistics is statistically significant.
Yes,
so
sir.
your overall the model is significant. If you want to report R square, adjusted R square, you'll have to take it from here.
Yes,
right?
sir. Yes, sir.
Because your model explanatory power is not changing. Only
Yes, sir.
thing, you are penalizing the standard error to ensure that less number of variables are reported to be statistically significant. That's the only thing. Okay. This
Yes,
is
sir.
the price you have to pay for not being able to meet many of the assumptions. Okay. Is this
Understood.
clear? And it's a standard practice in research paper. This is how the reporting is done. You can check any research
So
paper.
do I have to report both the things, like the fixed error results and standard error results, or only the last, that is the robust standard error results?
And only this one. Only this one
Okay,
you have
sir.
to report. Only these variables. See these coefficients, and whether it is significant at 1% level, 5% level, or 10% level,
Yes, sir.
and the corresponding t-value. Right?
Okay. Understood, sir.
Plus overall model significance, F statistics. If you want to report R square, that also you can report. But in good research paper, I do not find R square being reported. They report overall significance of the model, that is F statistics, whether that is significant or not, because that tells you whether overall the model is significant or not, and then each coefficient of the regressor, right? That you have to report, and you have to also mention that you have used robust standard error. That's the case.
Okay, sir.
Okay.
Understood.
Is it clear?
Understood, sir. Yes, sir. Yes, sir.
And you see that I have taken the robust standard error in the CSV file, because that is what I will be reporting. Correct? Okay. Everyone understood this? Yes or no?
Yes, sir.
Yeah. Next. Now, as I told, I'll have to use alternative measurement technique. I am reporting this result based on what? ROA as dependent variable. But if I treat Tobin's Q as dependent variable, can I conclude more or less broadly the same result? This is called robustness test. So this, what we did is our base model. Now I am testing whether the base model result is robust enough. That means if I change the dependent variable, can we still conclude the same thing, right? Is it clear? This is something very, very important for good research paper. You have to do this. Okay. So what we will do now, we will try PQ as the dependent variable. Tobin's Q as the dependent variable. I will just give you the codes. I'll just give you the codes. Please take the codes. And rest of it is same. Estimation process is exactly same, right? Only instead of ROA, now I am using what? I'm using Tobin's Q, right? I'm using Tobin's Q. So you see the code, everything else is same. Instead of ROA, now I am using Tobin's Q. Okay? Are you able to follow me? Yes or no?
Yes, sir.
Yeah. Please run the codes.
Sir, what if we have more than one dependent variable? For example, to measure the financial performance, we are taking 2-3 variables. Then the
No,
process.
so you have to, if you are taking, I'm showing you 2. You might have 3. You might have 4.
No,
you have
sir.
to run.
What if to measure the financial performance, is it that we have to take ROA at one time and then Tobin Qs and then other ratio at one time? Is it possible that we take 3 dependent variable together?
It's possible. Again, you have to use PCA and create a composite index for financial performance.
Okay, sir. Got it.
That is why PCA is a very powerful technique.
Right, sir. Right.
So what I could have done, say, I'll show separately the impact of ESG on ROA. Separately, I'll show impact of ESG on Tobin's Q. And then I will create one index for financial performance using both ROA and Tobin's Q. And then I will show what is the impact of ESG on that index of financial performance. So if you have 2 variables, better not to go for index, but more than 2 if you have. Suppose you have 3 metrics for financial performance, then you can create one index and show how the ESG variables are impacting that index. So that can also be a next level of robustness test. Okay. That can also be done. Okay. Understood? Yes or no? Is it clear?
Yes, sir.
Yes, sir.
Yeah, understood? Okay. So just run the model and tell me whether we are getting similar result or not. You won't get exactly similar thing, but see what is happening here. So here my main variable is having statistical significance and positive relationship as it was in the base model, right? LNTA sign wise it is same, but it is not statistically significant. CAR is statistically significant and having same sign. Gross NPA is not statistically significant, but having difference in sign, but it is not statistically significant, so we should not get into it, right? So my main variable is having the same symbol, the same sign, and it is also statistically significant. Okay, but if you do the robustness and just complete the rest of it, the residual plot, so this result is not actually violating or deviating from the main conclusion that we drew in the base model. And you see residual plot is quite okay. And here also you can report robust standard error as we did in the previous case, and check how many variables are finally statistically significant. Okay, so you can see after using robust standard error also my this one is statistically significant and CAR is still statistically significant. So my main concern should be at least this one should be statistically significant and should have same sign, because that is my main variable of interest. Yes or no? Is it clear? Understood? Yes or no?
Yes, understood, sir.
Now, what is the next level that you can do? I have run the impact of, I have modeled the impact of ESG, composite ESG score on ROA as well as on Tobin scale. Now you can do individually. What is the impact of E on ROA and on Tobin scale? What is the impact of S on ROA and Tobin Q? What is the impact of G on ROA and Tobin Q? So you do that as an exercise at home. Okay? Is it clear? Understood what I just said?
So please repeat, sir. Please repeat, sir.
I just did impact of composite ESG score on ROA as well as on Tobin Q.
Yes, sir.
And what is the impact? Impact is positive.
Positive.
That basically means firms that are doing good, following good ESG practices that reflects positively into their performance. That's what the basic interpretation is. Yes or no?
Yes, sir. Yes, sir.
Right. And this is a popular notion because that is why people are, regulators are trying to push all the banks to, do sustainable practices, follow sustainable practices, right? So that is basically measured by ESG practices. But what about individual component of ESG? We computed composite score. What about individual component score? How does E score impact ROA? How does E score impact Tobin Q? How does, so instead of now ESG composite score, I will take only E.
Yes, separately, sir. ES.
Separately.
Yes.
Separately for E, separately for S,
Separately for G.
So this will make your paper even more, stronger, right? In terms
Yes,
of
sir.
possibility to get published. So please do that as an assignment, as an homework, because same process you will have to follow, right? Instead of ESG, everything else will remain same. Instead of ESG, I will first take E, then I will take S, and then I'll take G. Can you do that? Yes or
Yes,
no?
sir. Yes, sir.
Okay.
Yes, sir. One question that, like in the current context, like we have 7 years data and 50 banks.
8 years data. 8
years data and 50 banks. So, sir, like in the first discussion, you have said that in order to run fixed effect, the T should be more than that is what N.
No, I never said that.
T should be, time can be less than N also.
Most of the times we have short panel. What is a
Yes,
short panel? Short funnel means your N is more than T,
Yes, sir.
right?
Yes, sir.
But the example that I took, in that case, we had six companies and 15 years data. That was
15
a
years
long
data.
time.
Yes, sir.
That does not mean that to run a fixed effect model, always you should have long funnel. No. But rather, we discussed this point, to do dynamic funnel modeling, you should have short funnel.
Okay, sir. But
Because of
if
this nickel
yes, sir.
bias.
Yes,
You
nickel
remember?
bias will be there, na, sir, if you done fixed effect.
Huh?
If
No,
in
so
the
that, no, if you have a short funnel where T is small and N is large, then nickel bias will be there. And that is why, to get rid of nickel bias, we use difference GMM or system GMM.
It is in the robustness check?
No.
Yes, we have conducted, but in the current context, sir, I'm saying.
In this context, we can do it as a robustness check, because we are doing static model as well as dynamic model.
Dynamic model.
Don't
Okay,
mix. I got your point where your confusion is coming from. See, when I'm saying that fixed effect model will have nickel bias, which fixed effect model I'm saying? Fixed effect model after including the lag of the dependent variable.
Yes, sir.
That will have nickel bias, but not this fixed effect model here. So I have not included the independent lag of dependent variable as regressor. So there is no question of nickel bias here.
Okay, sir. Understood, sir.
I'll talk about that in the next part. Okay.
Okay, sir. Understood.
Got it. So don't
Yes, sir,
get
yes, sir.
confused. When you include the lag of the dependent variable as one of the regressors in your model, and if you run a fixed effect model, then
nickel chances of nickel bias arises.
Yeah, then nickel bias will be there if the panel is a short panel, right? Because nickel bias is of order 1 by T.
Yes,
coming to
understood.
that point, but don't get confused. This is not here. Nickel bias is not relevant because I have not included the lag dependent variable as one of the regressors, right? Yes or
Okay,
no?
sir. Yes, sir. Yes, sir. Yes.
Okay. So till now we have done the static modeling and you understood how to go about it. Now we'll go for dynamic modeling, right? So in dynamic modeling, you tell me by default what will be the choice? Two-step system GMM. Yes or no?
Yes.
By default, what should be the
Yes, sir.
choice?
Two-step system
GMM. But if you want a verification, or if you want some kind of analysis before you decide that two-step system GMM is the model to go for, you can do that. First, you define what is the upper limit and what is the lower limit. Then you run the difference GMM model and see whether it is biased downwards or biased upward. Based on that, you can take a call whether you should go for system GMM or difference GMM. By default, I am telling 99% of the cases, the answer will be what? System GMM. Okay? That
Yes,
too,
sir.
two-step system GMM. But let me just do that basic things. And since we were talking about the nickel bias, we will just do that. First, we will decide what is the upper limit, lower limit. Then we will run the difference GMM model and see whether it is upward biased or downward biased. And based on that, we will take a call whether we should use system GMM or difference GMM. Even without doing that, we can conclude that system GMM will be the answer because that is more efficient because of the way system GMM handles the instruments. If you recall, in system GMM, what happens? It has both the level equation as well as the difference equation. For the level equation, the lag differences are used as instrument, and for the difference equation, the lag level variables are used as instruments. So both the things are used as instrument. That's why it is much more efficient than difference GMM. So by default, answer will be system GMM. But if you want to check, then you can go ahead the way I'll be just explaining. Okay. Now, so what is the first step? We will run the model using pooled OLS, right? But since it is a dynamic model, I will include the lag dependent variable as one of the regressors. Okay. So can I just give you the code? Please, everyone take the code. And then we will do step by step, right? So first, let us do up to this, that is pooled OLS. pooled OLS. Should I give you the code in the group? Yes or no?
Yes, sir.
Yeah, I have given the code. Please check. And you see how challenging it is to make sure that with using one data set, you meet all the requirements of all the models. That is really challenging. That is why robustness test is the place where we most of the times fail in research paper. Okay, have you got the code? Let me run the codes one by one. First, take a look at this code. What is this code? I have named this model as pooled model, right? I'm using simple linear model because in pooled regression, anyway, panel structure is ignored, right? ROA is the dependent variable, and look at the independent variable. First independent variable is what? ROA lag. We have already created ROA lag earlier, right? Now, Partho, pay attention here. This is what I was talking about.
Yes, sir. Yes, sir.
So, yeah. And rest all are same, right? And what I have done, I have also included the time dummies. What is this? Factor in bracket here means what? It will consider all the time dummies. Okay? Because when I run the fixed effect model, I will use two-way fixed effect model. So here I should also include what? The time dummy. But I will not include the bank specific.
Yes, sir. Cross section.
Bank specific fixes I will not include because in
Yes, sir.
pooled OLS we ignore
It
that.
is assumed to
Right?
be fixed. Yes, sir.
Got it? So please run this model. And if you just look at the summary, what is the main interest here? This number, right? Coefficient of the lag dependent variable, because that serves as the upper limit. Yes or no? Do you remember?
Yes, sir. That was the upper limit and fixed variable
So it
volume.
is approximately 0.7. 0.7
Yes,
is
sir.
the upper limit.
Yes,
Right?
sir. Yes, sir.
Now just complete the rest of it. Just residuals, just a formality because it is anyway not required for further analysis. But if you, for your own satisfaction, okay, manageable because it is a faulty model, we all know, right? Yes or no? Because here we are not able to, the endogeneity problem is not solved, right, in this model. Yes or no?
Yes, sir. Yes, sir.
Because once I include the lag dependent variable as one of the regressors, I am inviting what? Endogeneity problem. I explained this in the last class, right? So that is not sorted. So next what I will do, I will run fixed effect model within group fixed effect model after including what? Lag dependent variable as one of the regressors. So I'm just giving you the codes. Please do it. Okay. So just look at the code. I have named this model as fixed effect within group FEWG, and we will be using PLM function because we are using fixed effect model. ROA dependent variable, lag of ROA is the one of the regressors because that is what it makes the model dynamic. Rest all are same. Model is within, and effect is two ways, right? Yes or no? This is nothing new. We have done this before.
Yes, sir.
And if I run the summary, okay. So in this summary output, what is the most important thing? This one. Coefficient of ROA lag. How much is this? 0.395. So
Approximately
0.4 is the
and
lower
0.7.
limit, and 0.7 is the upper limit.
Upper bound.
Right?
Yes, sir. Yes, sir.
So basically all your if your difference GMM estimate falls below 0.39 or is somewhere close to 0.39, then it is biased downwards and you should go for system GMM. That is the verdict, right? Yes or no?
Yes, sir.
This is what we discussed last class, right?
Yes, sir. Yes, sir.
So both are done, and you can just plot the residual if you want, residuals, but it is of not much use because anyway, this is also a faulty model. Why this is a faulty model? Because this has nickel bias. Yes or no? This has a
Nickel bias, sir. Yes, sir.
Correct. So next, what I will do, I will run what? Difference GMM model. Okay. I will run difference GMM model. But I know that difference GMM model is not my best model because this is I am just doing to be double sure that system GMM is the model to go for. Okay. Okay. So let us run the difference GMM model. I will run two-step difference GMM model. So I'll just give you the codes for two steps different GMM model. And let me give you. And I think last class Partha was asking how to get the instruments, right?
Yes, sir.
Number of instruments. You asked this
Yes, sir.
to Shweta ma'am, I think, in Shweta ma'am's class.
Yes,
you
sir.
asked.
Sure. I asked her.
So I will tell you how to do that because that is important for reporting in the research paper, right? Because reviewers want that your instrument number should be less than the cross-section unit, right? Number of groups.
Of
That you
groups,
have
sir.
to
It should
ensure.
be less than number of groups.
Otherwise, your paper will never be accepted.
Yes, sir. Yes, sir.
Correct. So now let have you got the codes? Let me run the model. I have named it difference GMM2 means two-step difference GMM. That's how I have named. You can give any name, not an issue, right? And you know this, right? This we did earlier, the formula and all those things. The only thing that I have added is this. You can always play with these lags and all. That is not a problem here. Only thing that I have added is this command, collapse. This is important to ensure that you do not have instrument proliferation problem. What is meant by instrument proliferation problem? That means if you do not have this command, then software will use too many instruments. But if you use this collapse command, then it will use instrument parsimoniously, which is very, very important because too many instruments might lead to overfitting, right? And if you have too many instruments and if the number is more than the number of cross-sectional units of group, your paper is anyway not going to be accepted. So this is a very, very important comment. So this is a new thing that I have added. Okay, please make a note of it. Run the model. Run the model. Rest all are same, right? Effect is two ways, model is two step, transformation is difference because I am running different GMM model. Is it clear? Everyone is clear about the code?
Yes, sir.
Yes or no?
Yes, sir. Yes, sir.
So just run the model and take a look at the summary statistics. What is the summary statistics? You are getting lag ROA 0.25, which is less than 0.4.
Less than in lower bound, yes, sir.
So it means what? Difference GMM is downward bias.
Yes, sir.
Okay.
Yes, sir.
So your verdict is you have to go for
System GMM.
system. Okay. So just do the formalities. If you want to find out how many instruments have been used here, so you can just run these codes. First run this code, then run this code. Okay. And how many instruments have been used? 16 instruments have been used. And how many cross-sectional units you have? 50, right? Yes or no?
Yes, sir. 50.
So it's not a problem, but anyways, this is not the best model for us, and we can always improve the result. But since this is not the best model, we will not spend our time on this. This is I'm using just to be double sure that system GMM model is the model to go for. And in fact, in research paper, you do not also have to report this, that upper bound, lower bound, and system difference GMM is downward bias. By default, your choice will be system GMM.
System GMM.
Okay? And this
Yes,
is
sir.
this is an established practice, so you do not have to report all these things in research paper. This is for your own satisfaction. or confirmation or double checking part. Is that point clear? Yes or
Yes,
no?
sir. Yes, sir.
So now the verdict is we have to go for system GMM. Let me just, for my own satisfaction, plot the residuals and check how it looks. It is better than the fixed effect model and the pooled OLS model, but still there is scope for improvement, right? Yes or no?
Yes, sir.
It's not the best model.
Yes, sir.
And we could have improved the result by adjusting the lag structure, but since this is not the best model, why to waste time on this? Because we will waste our time improving the system GMM models, right? Because that's the model we have to go for, and that's the model we'll report also in the research paper. Is it clear? Up to this, are you with me?
Yes,
so
sir.
far? Have you
Yes, sir.
understood
Yes,
how
sir.
to approach a research paper? See, this is a very tedious process. You have to do so many permutation combinations and all those things. Okay, next. So now I will run two-step system GMM. I will not waste time in one-step system GMM because I want to ensure that I'm doing the adjustment for heteroscedasticity, because that's the fact. The way we reported robust standard error in fixed effect model for static, similarly, we will by default always go for two-step system GMM, not one step. Is this point clear? Yes or no? Yes or no? This is what I explained last class. What is the difference between one step and two steps? In one step GMM, we do not make adjustment to the covariance matrix, which is used to calculate the standard error and all those things, right? Because we are assuming that heteroscedasticity is not a problem, but by default we know that is a problem, right? We need to adjust the standard error and the matrix.
Yes, sir.
Right?
One
That
step
is
assumes homoscedasticity and two step assumes heteroscedasticity.
yes. So, but heteroscedasticity is the reality, right? So by default, I will go for what?
Yes, sir.
Two step.
Two step. Yes, sir.
So let us now give you the code for two-step system GMM with your the dependent variable is ROA. And we'll also run this same model taking Tobin's Q as the dependent variable because we have to do the robustness check, right? So I have given you the codes, and these codes are very, very important because these output we need to report in the research paper, right? So let us take a look at the command. Everything else is same as we did last class. I have only added the collapse option just to ensure that too many instruments are not used, because if we use too many instruments and if that number becomes more than the number of cross-sectional units, paper will not be accepted, right? So rest all are same, right? And you see transformation is what? LD, level difference. So let us run the codes one by one. I'm not getting into the code per se because we already explained in the last class how to go about this code. Is that fine with all of you? Yes or no? Yes or no?
Yes, sir.
Yeah. So run the code and look at the summary, okay, and see whether you are able to meet the diagnostic or not. And this system GMM is the best model simply because in the output only you have all the diagnostic reported, right? So right away you can see whether the model can be accepted or not, right? You do not have to run the diagnostic separately. So first of all, your lag ROA is statistically significant, positive. Then your composite ESG score is having a positive impact and statistically significant. CAR and GNPA are statistically significant and the signs are as expected. Yes or no? Yes or no?
Yes, sir.
So it is going with the static result, right? Yes or no? In static model also we got the same result, similar result. Yes or no?
Yes, sir. Yes, sir.
Now we have to check. What about the Sargan test, which talked about the instrument validity? I told
332.
you 332. So it
It
is
is also
within that
good.
0.1 to 0.4 reason. It's in fact very good, right?
Yes, sir. Yes, sir.
Yes or no? Autocorrelation, first order autocorrelation, is it there?
Yes, sir.
Yes,
It
it
is
is
there.
there because this
But
is
second order it is
0.
not there.
And second order autocorrelation is not
Not
there,
there. Yes, sir.
right? And these two are not that important, but if you can meet, very good. But at least these three we have to meet. Sargan, that is instrument validity, should be there. First order autocorrelation should be there. Second order autocorrelation should not be there. These three we must meet. On top of it, if we can meet these two, very good. Wild test for joint significance of coefficient, yes.
Significant.
And joint significance for time dummy is also there at 10% level. Okay.
Yes, sir. Yes, sir.
Okay. So the model is pretty fine. We can easily go ahead and report it. Not an issue at all. Right?
Yes, sir.
Okay. Is it clear? Understood, everyone?
Yes, sir.
Yeah.
Yes,
So
sir.
it's a good thing, and we can defend our static model result. Things are not changing. Only thing here we have included one lag dependent variable, and that too is significant, right? Please remember, if your lag dependent variable is not statistically significant, then you cannot defend your dynamic model. Yes or no? If
Yes,
your
sir.
lag dependable variable is
Not significant.
not significant, then there is no point using what?
GMM.
GMM or any dynamic model for that matter, right?
Static panel will also work, sir, in that case.
So static panel is the model to go for.
Is the model, yes.
Because if you are using dynamic model, because why are you using dynamic model?
Because
you
they lag
think
dependent variable.
you think that the dependent variable is persistent in nature. That means its current value is influenced by its past value.
Yes, sir.
So the lag dependent variable must be statistically significant. Otherwise, your dynamic model will not be defended. You cannot defend the dynamic model.
So
Okay.
in the main model, since we have done static panel, we have used. So in the robustness check, if we use that JMM and the lag dependent variable is not significant, will it work, or like we have to drop it?
No. It will not work, because then it is not working as a robustness check, because it basically fails one of the prerequisites. Okay. So in that case, you have to use some other static model as robustness check.
For example, sir.
For example, you can use for example, in this case, you have fixed effect model, right? Within group 2A fixed effect model 1. Second, you can use another version of fixed effect model where you use the industry fixed effect. What do I mean by that? Instead of using Banks fixed effect, you use a dummy for sectoral, heterogeneity. Say for public sector bank 1, private sector bank
0. Okay.
Now this is a time invariant variable, right? And it absorbs all the bank specific fixed effects.
Yes, sir.
So you can use that as an alternative to your
static fixed effect model.
Right?
Okay.
In fact, similar thing I have done in one of my papers in ETW, right, which is under review. And in fact, the feedback is good. Probably it will be accepted. So there we did like this. I did not use dynamic model, but one model I used this fixed effect within group without taking into consideration the sectoral heterogeneity. The other, as an alternative to that model, I have used sectoral heterogeneity. That means sector specific fixed effect I have used as an alternative, and kind of results were more or less similar. So that is another way of doing it. Okay, is it clear? You understood?
Sir. Yes, sir.
Yes or no?
Yes, sir. Understood, sir.
Next, what is the next thing? So how much we have done in this? We have So we have, so let me check whether we are able to meet the number of instrument criterion or not, right? So run the model. Run the model. How many instruments I have used? 22. Okay. What is the number of my cross-sectional units? 50. So I am within limit. Not an issue at all, right?
Yes, sir. Yes, sir.
Yes. 22 instruments I have used. The cross-sectional unit is 50. So all the criteria that I need to meet, I have met. Not an issue. So I can easily defend this result.
Sir, can you mute the microphone of Shwikriti? I guess it's making noise. Her mic is on.
Okay.
Oh, she's turned it off.
Okay, fine. Now let me just are you able to understand now what I'm saying? Yes or no? Correct.
Yes,
Up
sir.
to this
Hmm.
instrument, and then if you this is the model to report. If you want to take a look at the residual, how it looks, so you can do that. And this is the this coefficient. You have to take it to Excel sheet also, so that also you can do, right? These are the codes for taking the so with this code I can take the coefficient to the Excel sheet, right? And if you just want to plot the residuals, so just go ahead and plot. I have already given you the commands and see what is happening. You see, this model is much better, no? Yes or no? Yes or no?
Best of all, sir.
Best of all, right? Because system GMM 2-step is best, right? So it should give best result.
Good.
Correct.
Yes.
And you see, we have done lots of work to get to this level, right? Yes or no?
Yes,
Got
sir.
it?
Yes, sir.
So now what we'll do, we will run the similar model, but use EQ, Tobin's Q as the dependent variable, right?
Yes,
So
sir.
let me do the code, and then after this we'll stop. And if there is any questions, we can take. So Control C and Control. So run this model and let us see. Meeting all the having similar result in all the models is really a challenging thing, but that is the requirement to get your work published in good journal. So let me run this model first. Let us run this model. Okay. And let us do the summary. So what is going on here? You see, please run the model, everyone, and check what is going on. Your lag dependent variable is significant. Main variable of interest is also significant, but it is significant at 10% level, right? Yes or no? And your CAR is also significant. So result is more or less in line with the previous model. You won't get exactly similar result. That is not possible. Okay. But is it passing the diagnostic test? Argon value is how much? 0.69. So it is okay. First order autocorrelation, is it there? Yes, it is there. Second order autocorrelation, is it there? No, it is not there. And these two are additional checks. Whether we are able to meet them or not, that's not a problem. Wall test for coefficient, we are able to meet it. All coefficients are jointly statistically significant. Time dummies are not statistically significant. All time dummies are not jointly statistically significant. That's okay. That's not a problem. Okay. Are you getting the result? Yes or no?
Yes, sir.
Yeah.
Yes,
So
sir.
you
Yes,
see
sir.
that I have defended the model using the static model, that too using two different measurement models. I have also defended the result using dynamic model, that too using two measurement models. And on the top of it, if you add the analysis for E, S, and G separately, plus if you do subsample analysis, separate analysis for government bank and separate analysis for private bank, now you can think, at least aspire for, say, B or A level journal, right? So this is what it takes, so much of things. That's why it is so difficult to get your work published in good journals, right? So few more things you can do here. What are the more things? Individual ESG analysis, plus you can do subsample analysis, right? So if you do all the things, you see how rich your analysis will be, right? And if you can kind of demonstrate similar result, not exactly same, broadly similar result in all such analysis, then definitely your result or conclusion is generalizable, right? Yes or no? Yes or no?
Yes, sir. Yes, sir.
Understood.
Yes.
Yes,
So
sir.
I could give you a broad idea of what it takes to publish in a good journal, and it is really challenging, no doubt about it. But at least you now know the tools. At least you know the tools, right? Yes or no? All
Yes,
scripts
sir.
are there.
Yes, sir.
Only now you have to figure out where to use which model. That also we have explained in greater detail, right? And now you need to apply these tools to your data set, but do not blindly follow any predefined steps. You should always be open and flexible, because with trial and error only you can improve your model. And if you are using system GMM, it's the best part is you have the diagnostic test in front of you. And there itself, looking at this number only, you can decide whether your model can be defended or not. If you cannot meet the autocorrelation assumption, your model cannot be defended. If you cannot meet the Sargan, if Sargan comes in excess of 95%, 90%, you cannot, p-value comes more than 0.9, cannot defend, right? So all these things you'll have to ensure, right? And let me just complete the formality and check how many instruments we have used, because that is also another criterion that you must pass. Number of instruments 22. Okay, so within limit, not an issue. And if you want to plot the residuals, that also you can do. These are for taking the output to Excel sheet. So, and then finally, if you plot the residuals, I have given you all the codes, right? Yes or no? Just run the codes and check what is happening. See, this is even better, it seems, right? This plot. Yeah?
Yes, sir.
Yes or no?
Yes, sir.
Good. Now, this gives you a satisfaction when you end with this sort of a plot. Yes or no? Correct?
Yes, sir.
Yes,
Yeah.
sir.
And I hope I could explain the whole process, how to approach, because I could have discussed other research paper, but that would be only a theoretical discussion, because I don't have access to their data, right? I cannot crunch the numbers and show it to you what is going on. So instead of that, I kind of simulated a data set that can be used to demonstrate how the static models can be estimated and how the dynamic models can be estimated, right? And this is the approach that you have to follow. I hope you have understood the whole process. Yes or no? If you have any question, please feel free to ask me.